Hello, my name is Elijah Maneha, and I'll be discussing something that I learned in Intro to Chem that I found quite interesting. So, in Chapter 8, we kind of discussed the idea between differentiating polar covalent bonds and non-polar covalent bonds. So, one way to tell if a covalent bond is polar is within the Lewis structure. We can tell that there is a lack of symmetry. For example, H2O is a good example. We see that within the bond of H2O, where oxygen is in the middle and then hydrogen branches out from oxygen, that each of the bonds are equally distributed within bonded electrons, and there is no lone pair within the central atom. So we know that it is going to be not polar, but non-polar. However, there are other bonds if the lone pair exists or there's a lack of distribution between the bonding of electrons, then the Lewis structure or the compound itself is going to be considered polar. Another way to tell it is the actual molecular model, the space filling model to be exact. We can see the difference between two separate species. The size difference is a dead giveaway, and that is contributed by the electronegativity levels and the difference between them. So the closer they are together, less than 0.5 electronegative levels, then it would be considered nonpolar. But if it's greater than 0.5 in electronegative levels, then it's polar. A good example is chlorine and fluorine. Chlorine and fluorine are so close together on the periodic table that if we were to look at their electronegative levels, it's less than 0.5. But something that's spread out across the periodic table, like hydrogen, oxygen, their levels would be greater than 0.5, making it that combination polar. And when referencing the different levels on the periodic table, the electronegative levels increase from bottom to top and then left to right. So you don't have to know the exact numerical value, but it's a giveaway when looking at the periodic table.